your final examination of your 12th class?
So maybe January end.
And we have to complete the syllabus on time also. Okay.
Okay, sir.
So about the assignment, I want to say that, am I audible to you clearly?
Yes, sir.
So about the assignment, I want to say that you have to check at the portal. There is a portal of Learnivio, and there you will
Yes,
get the assignment given by me.
Okay, sir.
And you can check the assignment from there, and you can solve the question and submit the assignment.
Okay,
And
sir.
when you will submit the assignment, uh, then we will discuss that assignment in the class. That will be better. Okay.
Okay, sir.
So I am just leaving this now, and from the next time, I am hoping that you will solve the assignment. Okay. So we
Yes, sir.
were on the electric field.
Yes, sir.
We were on the electric field. So I have told you the electric field is a space or a region around a charge in which another charge experiences an electric force. Experiences an electric force.
Yes, sir.
If you put a charge here and around this charge creates the electric field. And if you place another charge in the region or a space around it, then that charge will experience a force. And I have told you electric field in terms of force. Electric field is equal to force on the test charge and divided by the test charge. Okay. And we have defined the electric field also. We have taken the test charge as 1 coulomb.
Yes, sir.
Okay. And when you will take the test charge 1 coulomb, then the force experienced by the unit test charge was the electric field. So an SI unit of electric field is Newton per coulomb or volt per meter. So after that, we have a topic. We want to calculate the electric field intensity for
Yes,
a
sir.
point charge. For a point charge, I have told you this is the point charge. Point charge means a very small charge, small amount of charge, you can say. So for a point charge, and this is a point charge, and we want to find the electric field here. We want to find the electric field here, and distance between this point charge and this point P where we want to find the electric field is R. And I have also told you how to find the direction of electric field. I have told you, suppose if you want to find the direction of electric field at this point, so consider here a positive charge. Consider here a positive charge, and due to this charge, this is also positive. Due to this charge, the direction of force will be in this direction. Direction of force will be in this direction due to repulsion. And I have told you the direction of electric force is same as that of electric field. Means in the direction of force, there is the direction of electric field. So this is the formula for calculating electric field, and this is the vector form. Vector form of electric field. So these things we have already discussed. Now we will discuss some question And I have also told you this K is constant, charge remain constant, but you will change the distance.
Yes,
You
sir.
will change the distance, then will increase the distance, the electric field will decrease. This
Yes,
is
sir.
the proportionality, means electric field is inversely proportional to the distance.
Distance. Yes, sir.
And the graph of this kind of equation is made like this.
Yes, sir.
And we have already discussed direction of field same as that of electric force experienced by test charge.
Yes.
Yeah. So now I am going to discuss a question that this is a graphical question. We have to draw the graph between the
Okay, sir.
electric field and the distance. Electric field and the distance. So the question is, a charge plus Q, this is Q, is placed on origin, plot electric field versus X graph for a region number one. If X is, this is X is greater than 0. Number two, if X is less than 0. And X is the distance. X is the distance. So this is the question.
Okay, sir.
Yeah. So suppose these are the axes, means this vertical line is y-axis, this is positive y-axis, this is negative y-axis. In this direction, when you will go, this is origin.
Yes, sir.
Origin, when you will go in this direction, you will get positive value of x. Positive value of x means this is positive x-axis, and this is,
Negative. X.
yeah, very good, negative x-axis.
Yes.
So this is the coordinate plane, and they are saying a plus q charge is placed here, means a plus q charge is placed at this origin, and they are saying when you are moving from origin to the on x-axis, from origin like this, when you are moving like this in this direction, draw the graph of electric field and the distance. So here electric field is on the y-axis, electric field is on the y-axis, and distance x is on the x-axis we will take.
Okay, sir.
So they are saying x is greater than 0. So this is the region of x is greater than 0. This from when you move from this origin to in this direction, you will get the value of x which is greater than 0. And when you will move in this direction, you will get the negative values. X is less than 0.
Yes,
This is
sir.
the region of x is less than 0.
Yes,
This is
sir.
the region of x greater.
Yes, sir.
So first answer, we have to calculate the value of electric field for x greater than 0.
0.
So for that, First, we should know what will be the value of electric field due to this positive charge. We have already discussed due to the charge, the electric field is given by kq divided by x square. Means I have replaced x r with x. Earlier I have written E is equal to kq divided by r square. Now
Yes.
instead of r is also a distance, x
Okay,
is
sir.
also a distance. Now we are
Yes. Yes, sir.
taking distance according to this question. So electric field you will get is inversely proportional to 1 by r square.
Square. Yes.
Yeah. So for x is greater than 0, this direction, now what you have to do for drawing this graph, you have to choose the direction of electric field. If the electric field is in this direction, if the electric field is in this direction, you will take the electric field positive. If the electric field, the direction of electric field is in this direction, you will take the electric field negative.
So we have to choose the direction, right?
Yeah, we have to choose the direction. We can choose any direction, means okay.
Okay,
But
sir.
I am just choosing
Positive.
positive direction of electric field will be in this direction. Positive
Yes,
direction
sir.
of electric field will be in this direction because it will be helpful for us. Because
Okay.
x-axis also means this distance also is positive in this direction. So according to the logic, we can take the direction of electric field in this direction positive so that we can easily draw the graph.
Okay, sir.
So I am just taking this thing, and after that I know that here x is greater than 0, means x is greater than 0, and from this positive charge, this is the positive charge, and if you want to find the value of electric field at this point, suppose here, so the direction of electric field will be in this direction.
Yes, sir.
The direction of electric field will be in this direction because I have told you if you want to find the direction of electric field at any point, and consider there a positive charge. So this is
Yes, sir.
positive and this is positive. This will repel like this. So means due to this charge, the direction of electric field will be in this direction. And distance is also positive. So means here in this quadrant, this is one of the quadrant. This is first
Yes, sir.
quadrant, second quadrant, third quadrant, and fourth quadrant. We
Yes, sir.
have electric field positive. We are getting this y-axis electric field positive. This electric field positive we are getting,
Yes, sir.
and distance x is also positive.
Yes, sir.
So these both things positive in this quadrant only. Means in first quadrant,
Yes,
electric
sir.
field will be positive and distance is also positive. So you will draw the graph like this. We have
Okay.
discussed this graph.
Yes, sir.
We have already discussed this graph.
Yes, sir.
And now we want to draw the graph for x less than 0. So x less than 0 means when we are going in this direction.
Second
So
quadrant, right?
yeah, in this direction. So
Okay, sir.
actually we have to check here the direction of electric field. Now this is a positive charge, and due to this positive charge, if you want to find the direction of electric field here, you will get direction of electric field in this direction.
Yes, sir.
Means you will get electric field negative here.
Yes, sir.
Means y coordinate negative here, and distance is also negative.
Yes.
Means x is also negative. So both electric field and distance negative will be in the quadrant. Which quadrant? Means
Second
electric.
quadrant.
No, in second quadrant, this electric field will be positive. Now, when you will take a point in this quadrant, so see here. Suppose here is a point P.
Yes, sir.
So this point lies in this second quadrant. Then this is the x coordinate and the y coordinate you will take.
Yes, sir.
So instead of x coordinate, you will have distance x, and instead of y coordinate you will have electric field. So
Okay.
now Ziyad, you can identify from here this point lies from origin in this direction. When you will move in this direction and in outward direction, then you will get this point. Okay. So
Okay.
when you are going in this direction, then you will get x as negative. X as negative, but you will move in the upward direction. In the upward direction. So means I want to say that in the second quadrant, electric field will be positive.
Okay, sir. Yeah.
Distance is negative. But in
Okay.
the third
Okay, sir.
quadrant, in the third quadrant, electric field will be negative because we are below the origin. We are below the
Yes,
origin.
sir.
So electric field is negative and distance. See, we are on the left side of the origin, so distance is also negative. So
Yes,
in
sir.
this quadrant, the graph will be like this. Graph will be like this. You can draw the graph like this.
Okay, sir.
Okay, Ziyad, you can just note it down.
Okay, sir.
In first quadrant, electric field will be positive and distance will be positive. In second quadrant, electric field will be positive and here electric field is positive.
Finish, sir.
Okay. We will solve one more question like this. In this question, we have to draw the graph for a charged particle, that is a negative charge particle placed at origin. Means a charge minus q this time
Okay, sir.
placed at origin. Draw graph of electric field versus x is the distance. So this is the same question as we have already done.
But with minus Q charge.
Yeah. Because the examiner will change
The values, yes, sir.
the values and all the things, but you have to just know how to, you have to understand how to draw.
Okay.
I am just trying one more time. One more time I am trying. So let's see. This is the we already know this is positive electric field. Positive means
Yes, sir.
this is on y-axis we are taking electric field. On x-axis we are taking
Distance.
distance. So this is plus
Okay.
x. In this direction when you will get, and in this direction is minus x.
Minus
And when you will go downwards, means here is negative p.
negative electric. Yes.
So Ziyad, first you should know this is the coordinate geometry of 10th class. So we know there in the this is the first quadrant. When you will take the first quadrant, so
Yes, sir.
suppose here, if you are in the suppose you are here in the first quadrant, and I want to locate you. I want to locate you. So location means I want to check your x coordinate or y coordinate at the same time.
Okay, sir.
So I'm just uh, explaining it again. Just be careful here.
Okay, sir.
Now if you are here, and you will always measure the distance from the origin. You will measure the position from the origin.
Yes, sir.
How you will get here? How you will get here? This point, draw line which is perpendicular to x-axis, perpendicular to y-axis. This distance you will get the electric field, and this distance you will get this distance x.
Okay, sir.
So now you want to check whether this x is negative or positive. So you are moving in this direction,
Yes, sir.
means here x will be positive.
Yes, sir.
And for electric field, you will move in this direction,
Yes, positive,
means
sir.
this electric field also positive.
Yes, sir.
But if you are taking another point here, so what you will do? First, you will draw the perpendicular on both the axes.
Yes, sir.
Now, this uh, this distance is x. This distance is x. Where you are, and this is electric field. This is
Yes, sir.
electric field. This is distance x. Means your x coordinate is x and y coordinate is e. And we
Yes,
will
sir.
check whether the sign of E and X. So see here, for checking electric field is positive or negative, you are going in the downward direction, in this direction, and in this direction electric field is negative.
Yes, sir.
So you will take electric field negative. So you are moving in this direction for X, means X is also
Minus
positive.
6. Yes, sir.
So X is negative and E is negative, you will get in this direction. X
Yes,
positive,
sir.
E positive, you will get in this quadrant. And
First
in
quadrant.
this quadrant, tell me what is X here? Here X negative, you will get X as negative here, and electric field here you will get
Positive, sir.
very good. And if you are in this fourth quadrant, you will get
Distance will
X.
be positive.
Distance will be positive, and electric field will be,
Negative.
means now you have understood the concept.
Yes, sir.
So now we can draw the graph very
Yes, sir.
easily.
Yes, sir.
Just so they are saying plus x. This is minus
Minus.
x plus e minus, and a negative charge is placed here, and we have to
Minus.
draw the graph. And we already know the shape of the graph is like this,
Yes, sir.
means the rectangular hyperbola graph. But
Yes, sir.
we have to choose the coordinate, in which quadrant we have to draw the graph. And they are saying the question is this. They are saying draw the graph for number 1 x greater than 0, number 2 x less than 0.
Okay, sir.
Can I remove this?
Yes, sir.
So now this, we want to calculate the electric field for x greater than 0 means this region,
Yes, sir.
x less than 0 means this region. For x greater than 0, for x greater than 0, find the direction of electric field here. Here is negative charge plates. If you will find the direction of electric field here in this quadrant, then you will get the direction of electric field in this direction.
Yes, sir.
Suppose here, if you want to find the direction of electric field, then your direction of electric field will be in this direction. So will this electric field negative or positive? We have considered in
Positive,
this
sir.
direction, in this direction, and in this direction. In this direction, the electric field we have considered positive.
Yes,
In
sir.
this direction, we have considered electric field negative.
Okay,
Okay.
yes.
So
Yes,
means this electric field is negative
yes, sir.
and x is positive.
Yes,
So
sir.
in which quadrant electric field is negative and x is positive? So
So, fourth quadrant.
electric field will be negative below the origin.
Yeah, fourth
Electric field will
quadrant.
be, yeah, electric field will be in the fourth quadrant. Very, very good.
Yes,
Means
sir.
x is greater than 0, but electric field you have to take as negative. So the graph
Yes, sir.
will be like this.
Okay, sir.
So for x, if you are now come here, x less than 0, x is less than 0 here. So here, if you want to find the direction of electric field, means if you are going in this direction, means
Yes, sir.
electric field is positive. So in which
Yes, sir.
quadrant this phenomena will take place? Not the
Second,
phenomena, not the
second
phenomena will.
quadrant.
Very good. Means
Yes,
you have understood the concept now.
yes, sir.
So just note it down. For drawing the graph, you have to consider the direction also. Which direction you are taking positive, which direction you are taking negative. I suggest you to take this direction, positive x-axis direction as positive for electric field also.
Okay, sir. Finish, sir.
Done.
Yes.
So our next topic is this. So write the heading: superposition principle for the electric field. Superposition principle for the electric field. Just wait a minute. I'm just.
Okay, sir.
Hello, Ziyad.
Yes, sir.
Actually, today I am not feeling well, so that is why I have to. Okay, Ziyad. So we will discuss the superposition principle for electric field. Okay. So
Okay, sir.
superposition principle we have discussed for the electric force also. We have already discussed. Okay.
Yes,
So
sir.
uh, electric field is also a vector. Electric field is also a vector. So I am just writing the statement for this first. So for a system of n interacting point charges and interacting point charges, net electric field at a point is vector sum of electric field due to individual charge due to individual charge. So the meaning of this is, suppose you have a charge placed here, you have a charge placed here. Suppose you have placed a charge here Q0. Q0 charge is placed, and here a charge Q1 is placed, here a charge Q2 is placed, here a charge is Q2 is placed, and accordingly you have n number of charges placed.
Yes, sir.
You have n number of point charges placed, and this is a positive charge I am supposing, and this is also I am supposing a positive charge. And Ziyad, we know that the direction of electric field is away from the positive charge, means due to this charge. uh, just remove this charge from here. Actually, sorry. Actually, we want to calculate the electric field at this point. Suppose at this point we want to calculate. So due to this charge at this point, the direction of electric field will be in this direction.
Yes, sir.
At this point, the direction of electric field will be in this direction. Is in this direction. Is in this direction. Suppose this is E1. Because this is also positive charge, this is also positive charge. Both will repel each other. And due
Yes,
to
sir.
this Q2 charge, the direction of electric field will be in this direction.
Yes, sir.
Suppose this is E2. And due to this third charge, the direction of electric field you can take in this direction. And accordingly, you can calculate or identify the direction of electric field due to all the charges. You can find the direction of electric field due to the charge Q4 placed here. As we already know that here n number of charges are placed.
Yes,
So,
sir.
at this point, the net electric field will be given by, suppose this is a point O, and I want to find the net electric field at point O, and this is given by the E1 vector addition of electric field at that point.
Okay, sir.
This is E2, this is E3, and so on, and electric field due to this charge.
EN, right?
Yeah.
Okay.
So Superposition principle is nothing but the vector, simply the vector addition of electric field. Vector addition of electric field due to the individual charge.
Okay, sir.
And if you want to calculate the E1, suppose this is a distance R1, this is a distance R2, this is a distance R3. If you want to calculate this E1, then we have the formula for E1 is K Q1 divided by R1 square.
Yes, sir.
And for E2, E2 means electric field due to this charge at this point. E2 is equal to K Q2
Q2.
divided by R2 square. So
R2
accordingly,
square.
you can find and you will put the value here and you will get the answer. You will get
Okay.
the answer. So this is the superposition principle, and we will solve question on this. So suppose here a plus E charge is placed, and here a plus 2E charge is placed. Here a minus 2E charge is placed, and at this point minus E charge is placed. Means this is a point, suppose A, this is B, this is C, this is D. And we have to calculate net electric field of given at center. Due to given charges. You have to calculate the net electric field due to given charge. So now you have to just calculate the magnitude and direction at the center of this, and it is given this that this is a side of square of side A. Means this is the square of side A. Square of side A. So if this is a square and suppose O is the center, O is the center of this square. So this is the question. Now we will calculate the answer of the question.
Okay, sir.
So see here, this is a positive charge. This is a positive charge, and due to this positive charge, first join the diagonals of this square.
Okay.
This is one of the diagonal,
Yes.
and this is another diagonal. Center of square means we have to find the electric field at this point O, which is the intersection of diagonal of square. So the distance OA, this distance will be equal OA, OB, OC, and OD.
OCOD. Yes, sir.
Yeah, because this is a square. OA, OB, OC, OD are equal, and the value of this distance is given by this whole distance AC divided by 2. When you will calculate this AC by right angle triangle, you will get A under root 2 divided by 2, and you will get the answer A divided by root 2. Means all these distances OA, OC, OD, BD, OA, OB, OC, OD equal to AC by 2, and that is A by 2. Finally, you will get.
So why did you take AC, sir?
Why? What?
AC, sir.
We can take, actually we know that both the diagonals of a square are equal. So if we will take dV, then dV will also equal to A under root 2.
Okay,
And
so you can take any side, right?
Yeah, any side. If you will
Okay,
do
sir.
half of dV, then again you will get A by 2. Because
Okay, sir.
square has every side equal and diagonals also equal.
Okay, sir.
I have just taken one of the diagonal. So first calculate the direction. Calculate the direction due to this is positive charge, and we want to find the electric field here. So due to this charge, the electric field will be here, EA, in this direction,
Yes, sir.
and this is a negative charge,
Yes,
and
sir.
electric field due to this negative charge will be in this direction because it will attract,
Yes, sir. That attracts, sir.
yeah, ED, and
Yes.
due to this +2 charge, the direction of electric field will be in this direction because here this +2 charge will repel, means you will get the direction of electric field here in this direction, that is EV. And
Yes, sir.
due to this negative charge, you will get the electric field in this direction,
EC.
EC. Very good. Ziyad, here direction is very, very important. We should know how to identify the direction. So,
Yes.
and and we know that if two vectors are in same direction, then we can add those vectors,
Vector
two
addition.
vectors, yeah, vector addition. From the vector addition, we can add two vectors. So the direction of this vector is same. So I am just taking one part of this. I am taking this much part of. So just focus here. If you add both the vectors, then you will get this is the diagonal, and here you will get EB plus ED. In this direction, the net electric field will be EB plus ED.
Yes, sir. Yes.
EB plus. And in this direction,
EA plus EC.
EA plus EC. Now we will calculate the value of magnitude of EA, EB, EC. So first calculate EA, and we know that this distance is A divided by √2. All the distances are A divided by √2.
Okay, sir.
So for calculating EA, what is the formula? KQ by R. K, Q we will take this E, and for R we will take A by √2. R square means KQ divided by R square means A by √2 square.
Okay, sir.
So this is KE, and you will calculate this will become A square by 2. So this will become 2KE divided by A square. When you will calculate EB, EBK, what is the charge we will take? 2E.
So for which one, sir?
Because we are calculating the electric field due to this charge. We are calculating the electric field due to this charge at this point. Okay.
Okay, sir. Yes.
So we will take K charge and divided by the distance this. Okay.
Okay. Okay, sir.
Yeah. In numerical, we have to just apply the formula. So this will become K into 2E into this will become 2 divided by A square. Then you will get EB 4 means 2 to the 4 K E divided by A square.
Square.
So now can you calculate ED and EC?
Yes, sir. I'll try.
First calculate EC. Simple. The value of EC will also, when you will calculate, you will get 2KE divided by A square. Because you can just calculate KE divided by square of this. And when you will
Okay, sir.
calculate ED, then
And it
again
will
you
be
will
K
get,
to E.
yeah, you will
Okay.
get 4KE divided by E square.
Okay, sir. Okay.
So now we in this direction, we will add both the vectors, and
Yes,
I
sir.
am supposing this EB plus ED is equal to E1,
Yes, sir.
and this EA plus EC is equal to E2.
E2.
Now calculate this E1. E1, when you will calculate, you will write EB, value of EB is 4KE by A square.
Yes, sir.
ED also 4KE.
Yes.
Now take the LCM A square. This will become 4KE plus 4KE. This will become 8KE
8
divided by A
is.
square.
Yes, sir.
Now calculate E2. Just E2 calculate.
2KE.
Yeah. At the same time, you have to see the direction as well as the magnitude.
Okay, sir.
E2 if you want to calculate. So E2 is equal to EA. Value of EA is 2KE divided by A square,
Yes, sir.
and value of EC is also 2KE
Yes.
divided by A square.
Yes, sir.
When you will calculate this, you will get A square. This will become 4
4KE.
KE divided by A square. Now we have two vectors. E1 and E2, and this angle of square between the diagonal, between the intersection of diagonals, means this angle is 90 degree always. In all these angles are 90 degree. This angle also 90 degree. In square, you will get this angle, means DOC is equal to 90 degree. We already know this. This is the property of square.
Yes, sir.
So we have two vectors at 90 degree, E1 and E2 at 90 degree we have. We want to calculate net electric field at point O. So what we will do, I have already told you, if two vectors are at 90 degree, then we will calculate the net by E1 square plus E2 square. So the value of E1 is 8KE divided by A square,
Yes, sir.
and the square of this plus E2 is
4KE
4KE.
by A square. Whole square.
So the net electric field at point O, now we will calculate, this will become 64.
Yes, sir. And 16.
Yeah, 64K square E square divided by A to the power 4. This
Yes,
will
sir.
become 16K square E square divided by A to the power 4.
4.
Now you will take the LCM A to the power 4 here, and when you will add this 64 plus 16, you will get 80
80. Yes, sir.
K square
E
E
square.
square. Now K, now this K will be KE divided by A square. You can take out of under root, and here we will get 80. So this is the answer.
Okay, sir.
Means you can write this in this form, like root 80 KE divided by A square is the net electric field at point O. So in this way, you have to solve the question. Each and every step I have shown to you. So just write it down.
Okay, sir.
And if you want to ask anything regarding the direction, regarding the how you I have calculated. Means if you have any doubt, then you can ask.
Okay, sir.
Just note it down.
So can you scroll down?
In a square, uh, the diagonals are bisected at 90 degrees.
Okay, sir.
Hmm. Sorry. Ziyad, I think you should revise this question at least 1 or 2 times.
Okay,
And
sir.
then you will get. In one time, I also cannot get this. When
Yes,
I when I
it's
was in 12th,
complicated, sir.
yeah, it is little bit complicated for you because you are the beginner in physics. But uh, if you will practice, then and only you can. No matter how much I am explaining, means how well I have explained this question to you, but whenever until then you have to revise.
Yes, sir.
Yeah, means I want to say that sorry, revision is the only key to get 100 out of 100 marks.
Yes, sir.
Yeah, I can just explain you in a better way, but you have to just revise that again and again. Try to think, how can I save my time in solving the question?
Yes, sir.
Yeah, and because practice, I have told you this question, but your responsibility now is to just think and revise. And if you are getting any doubt and any problem, then you can ask me. You can always free to ask in the class
Okay, sir.
anytime. Yeah.
So can you scroll down? So can you zoom in a little bit?
Yeah. Zoom in. Okay, fine.
Yes, sir.
Yeah. Is it fine now?
Yes, sir. It's okay.
Yeah. Actually, when we solve question, na, so I think there most of the students getting problem in solving the question. Am I right or not?
Yes,
In
sir.
in when the theory part is okay, but when the numerical part, when we talk about the numerical part, then they will not solve that part easily. The reason is that because see in this question you can see there are lot of things in one frame.
Yes, sir.
Means you at the same time you should know the formula of electric field. At the same time you should know how to calculate the direction of the electric field. At the same time you have to put all the values in the formula, different values in the formula, and calculate the magnitude. And also also you should know how to calculate the two vectors, how to calculate the two vectors when two vectors are in same directions, how to calculate the resultant when two vectors are at 90-degree angle, how
Yes,
to
sir.
calculate the resultant. So I have tried my best that I can tell you each and everything, but sometimes it is, sometimes you can understand it is not possible to tell all the things, means the properties of square and all that. But uh, like in this question we also know, we also already know that uh, the properties of square, in square have four sides
Yes, sir.
equal, and the diagonals of square bisects at 90-degree angle, and what is the length, how to calculate the length of the diagonal. So this thing we have to just understand.
Yes, sir. The vision, sir, you said.
Yeah,
By the vision.
no matter how good I am teaching, but at the end of the day you have to just revise it properly and ask me the doubts are very, because when we revise there is no person in this universe getting not getting any doubt. I don't think so. When you will revise, then you will absolutely you will get the doubts. If you are not getting doubt, then no problem, but when you will get the doubt, and you should discuss that doubt.
Yes, sir.
Because our motive is to spend 1.5 hour here. Why we are spending 1.5 hour? Because we want, I want that you should get higher marks in the exam.
Yes. Sir, can
And
you zoom out, sir?
zoom out.
Yes, sir.
Why?
So I didn't finish the last part, sir.
Oh, sorry.
Yes, sir.
Actually, I have made the slides to save the time.
Okay,
So
sir.
okay, now you can. Yes.
Yeah, only last part I need to write, sir.
In this chapter, you will face little problem because there are a combination of things here. Means you should know the vectors and all that.
Yes, sir.
Means you should have the knowledge of geometrical figures like square, triangle, rectangle. So,
Finish, sir.
yeah, very good. So next topic is the neutral points. So neutral means when there is no electric field. Neutral point is a point at which the zero electric field, at which there is a zero electric field. Simple.
Okay, sir. So there is no electric field.
I'm just writing the definition and all the things. So neutral point means, mm, first we will write the definition, then I will explain that. So
Okay, sir.
point at which electric field of individual charges cancel each other, or you can say neutral points are the points have zero electric field. So zero electric field means here is a plus Q1 charge is placed and suppose I have placed a plus Q2 charge here, and this is the line joining the two charges. So we have already discussed that in between two positive charges, if we place a negative charge, here, suppose minus Q is the charge you have placed at this position.
Yes, sir.
Now calculate the electric field due to this charge. Due to this charge, the electric field will be in this direction.
Yes, sir.
This is charge 1. So electric field will be in this direction, and due to this charge, the electric field is in this direction. This is due to charge.
Yes.
And if E1 is equal to E2, if
Yes.
E1 is equal to E2, then you can say both the two vectors are there, two equal and opposite vectors at this point. So at this point O, net electric field is equal to 0.
Yes, sir.
Equal to 0. Okay. So one more point you should note it down, that suppose if you have a charge Q1 and if you have a charge Q2, and if the if there is a neutral point here, suppose N is the neutral point, so you will, if Q1 is greater than Q2 in magnitude wise means suppose Q1 is 5 coulomb charge and Q2 is 3 coulomb charge, so that it means Q1 is greater than Q2. Then
Yes,
you can say that neutral point of system of 2-point charges lies near the smaller charge. Suppose the distance between the neutral point and this charge Q1 is x1 and distance this is x2. So when you calculate the distance, always distance x2 is greater than distance x1.
okay, sir.
Yeah. So now we will find the neutral point of the symmetrical charge system. Neutral point. So if you will calculate the electric field at this point, you will get the value of electric field 0. Net electric field due to this charge and due to this charge is equal to 0 here. So now just note one more point. Electric field at the center of symmetrical system is 0. Electric field at the center of symmetrical charge system is 0. So just keep this point in mind. Symmetrical system means I am just telling here. Suppose number one, you are having 2-point charges. you are having 2-point charges. Suppose here a plus q charge is placed, and here also a plus q charge is placed. So this is a symmetrical system. See, both the charges are equal and have the same sign. So,
Yes, sir.
so neutral point of this kind of system, neutral point means the electric field will be zero at a distance which is equal from this charge and from this charge. So if this distance is a, then this distance is also a.
Okay, sir.
So n is the neutral point.
So basically the center, right, sir?
Yeah, this is center basically. Obviously, this is center because the distance is this a. If this a, suppose I am having this pen,
Yes, sir.
and here is a point. I am
Yes,
just
sir.
here is a point now.
Yes, sir.
So if the distance, this distance and this distance is equal, so I will say this point is the midpoint of the pen.
Yes, sir.
Second, suppose we have the triangle and plus q charge, 3 plus q charge are placed at 3 vertices, and this is the center of centroid of this triangle. O. So this centroid O will be the neutral point. So this O is the centroid, and this centroid will be the N. N means neutral point. So this is also a symmetrical system, and if this is a equilateral triangle. Now, method. I am taking the square. Suppose plus q charge are placed like this, and this is the square of side A. So at the center of this square, you will get the neutral point at the center.
Okay, sir.
We have discussed this center of the square.
Yes, sir.
These dotted lines are the straight line. O is the center of the square.
Oh, sir.
Center of the square, and this center is the neutral point for case of square. Suppose if you have a regular pentagon, regular pentagon. If you have a regular pentagon, means like this,
Yes, sir.
like this, and like this. This is the regular pentagon, and all the sides of this pentagon are equal. This is a pentagon, and all the sides are equal. This is side A, this side A, this is A, this is A. So at the center of pentagon, O is the center of pentagon, and at the
Yes, sir.
center of pentagon, you will get neutral point. O is N. N means neutral point.
Yes, sir.
And Ziyad, what is the meaning of neutral point?
Neutral means that there will be no charges, right?
No, neutral point means charges will be there, means at not at the neutral point, but the main thing is the electric field due to all the charges at that point is zero.
Zero. Okay. Yes, sir.
So we have discussed this here.
Yes.
Point at which the electric field of individual charges cancel each other, or you can say points have zero electric field.
Okay, sir.
Now I am taking one more system, fifth system, infinite point charges. Infinite point charges means if you have a circle and on this circle there are infinite positive or negative point charges. Or you can say uniformly charged circle. If you are having a circle and having a positive charge distributed on it, so you will say this is a uniformly distributed charge. We can say that at the center of this sphere, the electric field is zero.
Yes, sir.
And so center, this O is the neutral point.
Yes.
O is the neutral point. Ziyad, are you getting what I am teaching to you?
Yes, sir.
Neutral point. O is the neutral point. So neutral point means net electric field equal to zero.
Zero. Yes, sir.
And if you are taking a negatively charged circular wire, or you can say negatively charged if you have a circular body and on this circular body you have a uniformly distributed negative charge, then at this center O the electric field will be zero, so we can say O is the neutral point. O is the neutral point. So this is a symmetrical system. What do you mean by symmetry, Ziyad? Do you know what is symmetry? Symmetry means uh, when you uh, cut a symmetrical system, you will get two similar system. Suppose I am just cutting this from here, so I will
Okay,
get
sir.
two equal systems. Means see this. I have get just this thing.
Yes, sir.
Means okay. Symmetrical when you will cut this from here from the center. When you will cut this, you will
Yes.
get two similar things.
Yes, sir.
So if you will cut this from here in the center, you will get two similar halves, similar equal halves.
Yes, sir.
So see this, these two charges cut this from here. Now this system is like looking like this now. This is a
Yes,
mirror image of this now, you can say.
yes, sir.
Just note it down.
Okay.
From here now, Newton points.
I finished this actually.
You have finished this.
Yes, sir.
This one,
Yes, sir.
mm, all of the things.
Yes, sir. Everything.
Very good. So I am taking just one question. We have a regular pentagon. We have a regular pentagon like this, like this, like this, and like this. This is a regular pentagon. Means what is the meaning of regular pentagon? Means all sides of the pentagon are equal,
Okay, sir.
and this is point A, this is point B, this is point C, this is point D, this is point E, and this is a center of regular pentagon O. So we have a regular pentagon of side A. At four corners, charges are placed. At charges are placed. So shown in figure. Shown in figure. So suppose at this corner Q charge is placed, 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 and on this corner no charge is placed,
Okay, sir.
and this Q is positive here. Q is positive. We have to find the electric field at this point O. Find electric field at point O. We have to find. So can you give me the idea how we will solve this question? You should apply your logic, apply your mind. Okay. So just I am solving, okay? Just concentrate here. So I have told you at the center of regular pentagon, electric field is
Sir.
0.
Yes, sir.
Means E at O is equal to 0 when we have regular pentagon.
Yes, sir.
Regular pentagon means a charge Q is placed like this, then this will become a regular pentagon.
Yes, sir.
And this distance, all the distances are equal, means OA, OB, OC, OD, all distances are equal are and given as A. Because this is A, so we can write OA, OB, OC, OD, OE all are equal because this is
Yes,
the
sir.
regular pentagon and this is equal to A. So can we find the electric field due to at point O due to A means electric field at due to point charge at A, electric field is EV. I can write EC plus ED plus E at E equal to 0 if this is a regular pentagon or regular pentagon. Vector summation of all the vector summation of electric field due to all the charges must be 0
Yes, sir.
at this point O.
Yes.
So we want to just find this value, electric field at point O we want to find. So I can write this as electric field at A plus electric field at B plus electric field at C plus electric field at D is equal to minus of electric field at vector, and take the magnitude on both sides. Take the magnitude on both sides. So we have to just find this. We have to just find this. This is the electric field at point this point O.
Oh,
Okay, because in reality we have only 4 charges: A, B,
yes, sir.
C, D. A, B, C, and this is
And
D.
yes, sir.
So we have to find EA, EB, EC, ED, and this is equal to EE. This is
Yes,
equal
sir.
to EE, and electric field due to charge at E will equal to K, and a positive charge we have placed there, and A square. So this is the answer of this. So EE is this. So you will get this answer. So just you can write this. This is equal to this is equal to KQ divided by A square. This is your answer.
Okay, sir.
This is little bit tricky question. You have to just think in it.